Modeling and simulation has been around for a really long time. There's been companies that have been very successful, Simulink being one of them. But there has been a lot of new innovations in the market. Today we are looking at different types of key architectures in automotive, like we have distributed, domain, and centralized. Now when you start looking at these architectures, it's not just about hardware, it's not just about software, it's hardware, software, and the communication and the scheduling. Now, when you have one variable, using something like an Excel spreadsheet works quite well, because you can just look at it at one point in time and it'll be similar at every point in time. But when you start looking at 3 and 4 variables, like in this case, you got the software, the network, the hardware, the scheduling, it's no longer just like one variable, and at that point, looking at just a point in time like an analytical model or a spreadsheet doesn't work to your favor. That's when you really need to look at modeling and simulation. So what does modeling and simulation provide you over an analytical modeling? Modeling and simulation is something where you're emulating what happens in real life, which means you have a clock that keeps changing time, just like real life. And just like how real life responds to different events, the events within this modeling environment also responds to different events. So for example, if you take a piece of software and the software is running on a single core processor, it's not just a delay of taking the software and just running the code, it's also that there's going to be a fetch stage where it has to go get the instruction. You have the load and store of the data to load it into registers, and then you have to execute on it. There's also a case of going out of order. You might have some of the execution units busy. So as you keep building it up, the complexity becomes so high that visualizing each of these individual components becomes very hard. And it's too late if you go and put it on an emulator, or too late if you decide you're going to put it on some FPGA board. That's one of the big reasons, the big trends towards modeling and simulation. Really what's happening in the world is that time is becoming a critical factor. Differentiation is becoming a critical factor. Say you bring out a product into the market and you suddenly find that it doesn't achieve the performance that is required, your reputation is at stake now. Or for example, your product has a recall. You have a PR nightmare. Right? Now, why don't people just do it? Right? It's because modeling and simulation is so new, especially when it comes to architectures, that there just aren't enough people doing this type of work. And that's where I think the kind of the reluctance to get on it. But once people figure out that it's not very complicated and it's not very difficult, you're starting to see more and more people adopt it. And I believe that these are some of the reasons why you're seeing modeling and simulation as a trend going forward. It's going to be something that's very critical, irrespective of which area you focus on.